Scale drawings. This is in our notes packet, page 8. A scale drawing is a drawing that shows a real object reduced or enlarged by a specific amount. This value is called the scale factor. A scale factor is a ratio of the drawing length to the actual length, usually expressed using a colon. Okay, so let's look at some examples. Just off the top of my head, scale drawings would include things like maps or blueprints, things like that are really important to use because people that are planning what they're building, or if you're using a map, you don't want a map that's actual size for somewhere you're going. You want a scale drawing so you can hold it in your hands, or in your hand on your phone as you go somewhere, right? Okay, the diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. This distance between the two towers measures 6.4 centimeters. So on the actual picture, they measured this at 6.4 centimeters. Now down on the bottom of this drawing, it says the scale is 1 centimeters to 200 meters. That's the scale of the actual blueprint drawing, or scale drawing. So we can set up a ratio of 1 centimeter to 200 meters. But then we need to make sure that we match up the units in the same order. So the distance on our drawing is 6.4 centimeters from one tower to the other. So since the top of our ratio here is in centimeters, and that's the scale part of our drawing, that means we're going to also put our 6.4 on the top of our fraction on our ratio. So then we're trying to find the actual length. So the 1 centimeter goes to 200 meters in actual length. That means we're going to be finding the number of actual length in meters between the two towers of this bridge. Okay, so we're just going to cross multiply now that we have our ratio set up. Cross multiply, so we have 1 times x. I'm going to completely ignore the units at this point because I made sure that the units matched up when I wrote the ratios. So now I'm just going to ignore them, other than when I get my final answer, my unit's going to be in meters. So I have 1 times x equals 200 times 6.4. Let's use a calculator to multiply that together. So 200 times 6.4 is 1280. So we have x equals 1280. Now, since we multiplied by 1, that means we already have our x answer. And so this is our final answer. It's 1280 meters from one tower to the other in actual real life. Example 2. You want to build a model of the Empire State Building using the scale 1 inch equals 250 feet. If the building is 1,250 feet tall in real life, how tall should your model be? Okay, so our model is 1 inch to 250 feet. This time we need to be careful because we have the actual size of the building that has to match up with our 250 feet. And we are trying to find the size of the model, and our answer will be in inches because our scale is in inches over feet. So this also has to be inches over feet. Let's cross multiply. So we have 250x, 250 feet times x inches, but we're not going to worry about the units because we already made sure they matched up before we started. And then 1 times 1250, so that's just going to be 1250. Take both sides and divide by 250. That will give us our dimensions for our model. So 1250 divided by 250 is 5. So our scale model is going to be 5 inches tall. Example 3. The distance from Magna to Logan is 72 miles. How far apart would the two cities be on a map that used a scale of 1 centimeter equaling 5 miles? So we have 1 centimeter to 5 miles. And we want to figure out how far apart the cities would be on a map. So how many centimeters they're going to be apart on the map. And the actual distance is 72 miles. Okay, so now we can cross multiply. We get 5x equals 72. Divide 72 by 5, going to give us a decimal answer, which is fine. So that means that our map is going to have a distance of 14.4 centimeters between the two cities.